Right. So basically, we want to look at SPSS. The purpose for this particular training is we want to be able to help students, especially academics and researchers who are into data analysis, to be able to begin that process, because there are a lot of students, a lot of yes, as it were, researchers and academics who are able to do their own research, but sometimes face some challenges when they have to analyze the data. So that is the main purpose for today's training, and I'm happy to have you all on board. Okay, so we're going to start. I'm going to share my screen now to, right. So I think you can see my screen now. Fantastic. Okay, so for today's engagement, we want to be able to look at an overview of SPSS. What is SPSS? And a brief tour of the software package. And so I did ask that for those who are registering for this particular seminar, this short training, I asked that you also make sure you have a copy of SPSS, maybe version 16 and above. For those who do not have any version at all, it's possible to get a trial version from ibm.com. So we want to look at a brief tour of the software, and then of course we need to understand what variables are, okay, measurement levels, the things that will help us to be able to actually conduct analysis using SPSS. From there, we will be looking at certain types of analysis that we can undertake. Univariate analysis, where we look at frequencies, descriptives, exploration and all that. And we will look at bivariate analysis. I will explain what all these things mean. And of course, correlational analysis. And we would not talk about some other types, multivariate analysis and some other types of regressional studies for this one, because this is an introductory and preparatory course, mainly to prepare you to begin to analyze your thesis and also other kinds of research projects. Okay, so very quickly, I want to mention that SPSS, of course, stands for the statistical package for the social sciences. This is a software program from IBM, and it's been in use since 1968. This is a very powerful software that is used for all kinds and manner of data analysis. And it's a primary tool that everybody who has plans to go into research and policy analysis, even student academic work and even academic researchers, this is a powerful tool that one must have. It is a very powerful tool that one must be able to utilize for their work. There are different types of files that SPSS works with. Mostly we will be dealing with SAV files, but remember there is a possibility of writing codes with SPSS, just like you do in Python, in R, in Stata, and some of those other data analysis softwares. So, but for the main SPSS file will be .sav. Portable files will not really be dealing with that. The output files, of course, when you run an analysis, it comes out in an output. So when you're saving that, it saves it as the .spo file. Right. So there are some things we need to understand about creating data in SPSS. I will just quickly show you. Okay, so I will just quickly show you. I'm going to be sharing. Right. Okay, so basically this is the interface. This is SPSS. And you would realize that there are several aspects. There are so many things on the window. This is called, this whole stretch, this whole range is the data editor, okay, the data window. And in this data editor, we have, or the data window, we have the data view down here, as you can see. Then we have the variable view. I want to believe that many of you might already have an idea what this means. Basically, the variable view is where you define the specific variables based on which you'll be collecting data. And data view is where you actually input what responses you have received after conducting your research. Okay, so as I was sharing, one very key thing that we need to understand in creating data files is that it's always important to assign an identification number to each case, okay? You need to make sure that for each case, each of your variables, there has to be an identification number. So for most studies, and for what we'll do today, we'll make sure that we have an ID that helps us to know which of the cases we're dealing with. Mainly because sometimes you may actually find that you are dealing with several hundreds and thousands of data, and that requires very important identification. The variables usually must have a variable name and also a variable label. The variable name is usually a shortened form of the extended variable name, which displays when you open the data view. But it comes fully when you generate analysis. When you conduct analysis and you generate output files, you are able to find the full label names in that. Okay, so of course, each variable will have to have a set of values, and I'll be explaining what all those things mean in a jiffy. You need to make sure a variable has some missing information. If there is any missing information, it should be represented appropriately, and all of that. So these are just introductory bits on the SPSS variable entry. Now, let's talk about a data view in the SPSS. Now, so when we say data view, let's understand basically that the rows, yeah, if I can just extend this properly. Great. So if you look at this screen, you realize that yeah, of course. Okay, sure. Yeah, so if you look at this screen, this whole portion of it, when you have these columns represent something different, and these rows represent something different. Now, what I want to say here for you to understand is that columns represent the variables, okay? When we say a variable, we mean the characteristic of the object of interest. What is the characteristic of the object of interest? So that is what we mean when we say variable. So the characteristics of the object of interest are captured on the stretch, which we call the columns above here. Now from the top here, coming downwards, these are your cases, the individual cases or observations, okay, the object on which data has been collected. So each of those cases that is captured. Let's say you collected data from 5 people. Each of those 5 people will be represented here. So you have one case here, another case, and then the variables are here. So if the variable is maybe ID, there is something there for case 1. If the variable is before, there's something there for case 1 as well. And then for case 2, for case 3, and so on and so forth. Yeah, so that is basically what we mean. Now, it is important to explain the definition of variables to you. Now, we're going to switch very briefly to this variable view, and then right. And then I'm going to be explaining a couple of things about what we have here in this view. Right. So as we mentioned, I'm going to just open a new clean sheet and then go to variable view. So as we explained, we've been talking about variables being, the objects that are under observation, or those specific features that are the variables or the characteristics of the objects of interest. They are in the column section. So now let's say we want to deal with 1. Let's have a variable name. Maybe we want to capture data. So the first thing we want to do is to give it an ID. Okay, so we will say we'll have an ID here. So the name of that variable is going to be ID. Now, when you shift to the next, you see type. Now, type simply refers to the type of data that will be entered in the data view. Okay, and right. So, for instance, if you take this, we have the type. I'm going to click on this, and you see these are all different types of variable types that can be input into this particular segment. So you have numeric, you have comma. Comma is when you have numbers, maybe numbers written like 2,000, and you see that, okay, let's say 2 million. That is about 6 zeros, right? So you have 2, comma 000, comma 000. That type of formatting is called a comma. So you put a comma. There are some in some places where they write, instead of using comma, they use a dot. So you find that normally if you have comma where you have 2, comma 000, comma 000, and then the decimal is represented by a dot, it is reversed in some places where they rather use the periods or the dots to represent demarcations of numbers, and then use the comma to represent the decimal place. So then you would select a dot. And scientific annotations, okay, sometimes you have 1E, F, 2E, 7D, those kinds of scientific writings you have to capture through this. If it's a date, you would have to select a date. If it's the dollar, you select a dollar, custom currency. Now, let me just focus on the string. The string refers basically to text, okay, information that is fundamentally text, but not always text, because when we say text, we mean that it can have numbers, okay, string values can actually have numbers in them, but those numbers are not mathematical. We cannot perform any arithmetic operations on them, okay? No mathematical operations can be performed. For instance, a phone number, okay, that is going to be a string value, even though it is numbers, but you cannot perform any kind of operational, you can't use it, it doesn't make sense mathematically, okay? You can't use phone numbers to do any kind of mathematical calculation. So that will be a string value as well, right? So, so at this point, you want to look at, over here, we're going to select string for this. I'll give a few details about variable naming, and then I think that will make a lot of sense for you. Now, when you come to width basically refers to number of characters that can be contained in, okay, in that particular column for that variable. Okay, how many characters can be input into that variable? So width here specifies that. Will there be any decimal numbers? Yes, if there will be, you have the opportunity of what? But this is a string value, so definitely there cannot be any kinds of what? Decimal numbers, because this is text. We don't do decimals with text unless they are numerical values. Now, label here is where you are actually naming as it were, the full name of the variable. Remember, as I said, here we've just put ID. This is a very brief and short name that we put there. But here, you can give it a more detailed name. Okay, maybe if it's you are dealing with computers, maybe you're collecting data on computers or something, or students, you can say, well, this refers to a student ID. Okay, so if you come to values, now values help us to be able to um, break down, as it were, right. Okay, so I think I might be, let me just share the right screen now. Right, so if you come here to values, you are able to define, okay, do you want maybe the cases that are going to be collected? Let's say for ID, we don't need to define any specific values. But if we're dealing, for instance, with gender, then we are going to have two categories. Maybe, we're going to have male, we're going to have female. So we can decide quickly to say, well, one will represent the male, and two will represent female. Okay, so we're able to do those definitions here. But for now, I'm just going to remove that because this particular variable does not require that. Now, missing numbers refer to, for instance, if there is no response from a respondent, what value should be there? How should SPSS interpret it? By default, if you put nothing there, a dot will be inserted in the data view. But you can choose to put mostly, 99 or 999 to represent the fact that no answer was obtained for that particular variable. All right, so column basically from here you're just dealing with aesthetics. Column basically refers to how wide, okay, this segment should be so that it can contain whatever data is going to go in there. Okay, now so for instance we have 8 here. If we were to increase this to about 50 and we go back to data view, you'll see that it has extended automatically. So basically, that is what column does based on the information that will be put there. Alignment simply talks about whether the values will be aligned left or aligned right. So you see, by default, if you have a string value, which is going to be text, it's going to be aligned left. And if you have a numerical value, it could be aligned right. Now, this part of it is so critical. Measurement levels, and I'll be spending some time to explain this. But right, so if you look at this portion, usually there will be about 2 or 3 options: the ordinal, the nominal, and the scale. Right. So let me begin by explaining what these mean very briefly. Okay, so I want to just share the screen again. Great. So I want to share Okay. Right. So I just want to share this. Get back to the presentation. All right. So as I mentioned earlier, columns and alignment, all of that, numeric variables are right-handed justified, and string variables are left-handed justified. Okay. So as I mentioned, that is basically it. Now I just want to talk about. Okay. So if you look at what we have here, we have levels of measurement, nominal, ordinal, interval, and ratio. Interval and ratio is usually combined and referred to as scale. And I will be explaining what I mean by those in just a moment. Great. I hope you can see my screen. Hmm. All right. So when we talk about measurement levels, this is so key to data analysis. Okay, how you are able to conduct your data analysis is very much related to your understanding of measurement types or measurement levels. Okay, so when we talk about measurement level, basically what we're trying to say is that now in each variable, how do the values in that variable relate to one another? Okay, and they are measured on three levels: nominal, ordinal, and the scale. I'll begin by explaining the nominal. Now, when we remember that there are two categories of data in statistics, you have qualitative data and you have quantitative data. And you know, qualitative data deals with uh, things what we call categorical variables or grouping variables, variables that are not specifically numeric in nature. Okay, for instance, when we ask of your name is a qualitative measure. We cannot quantify your name statistically. Okay, so those kinds of things that deal with name and marital status and things like that are generally just qualitative. Then you have quantitative, where you deal with numbers. Okay, something that can actually be quantified and measured. For instance, when we ask of your age can be measured in years, in months. Okay, so a quantity that can actually be measured is something that is actually quantitative. So age, height, weight, and all of that. These are things, even distance, okay, in kilometers or in miles, can be measured. Your height can be measured. And so those kinds of variables are called uh, quantitative variables, or sometimes we call them continuous variables. Don't forget, qualitative variables are usually called categorical variables or grouping variables. Now, when you have, say, a nominal um, variable, as I was explaining earlier, it means this variable is not a quantitative variable. This is a categorical variable that has no numerical features or does not have any quantitative elements. Now, let's say ordinal. Ordinal basically deals with levels, okay, and of groupings. For instance, if you talk about something about, let's say, your level of education, you know that um, primary school is lower than junior school, junior high school. And junior high school is also lower than, senior high school is higher than junior high school, and universities are higher than senior high school. So there is some level of ordering. So the word is order. There is some level of what ordering in there. So you go from KG or kindergarten, you go to primary, you go to JHS. The same thing applies to, let's say, satisfaction. Okay. Um, Maybe, or even agreement. So a question goes like, do you agree with this? You say, I agree, strongly agree, disagree, strongly disagree. These are all levels. And so such kind of data is considered ordinal data. Okay. Now, what about the scale data, where we have interval and ratio combined? Basically, that is where you're talking about quantifiable elements, as I explained earlier. So when you have to put in a number that is quantifiable, measurable, age, and um, um, height and weight and all of those kinds of data, even income, okay, amount of money, these are numbers that are quantifiable, and so they considered scale data. Okay, so remember, mostly when you have numeric variables, it's likely there will be scale variables. And when you have string variables, they are most likely going to be nominal. Right. Okay, so we are going to be delving into some of the kinds of analysis that can get you started with your research as a student or as an academic. And just before we do that, I want us to once again look at okay. I want us to just look at the main data. Okay, now, so I want to put this across. Okay, for instance, if you see ID, as I explained earlier, ID does not represent a number that can receive any kind of mathematical operation. We could as well represent ID with just a text and not, a number. But a few things you need to know when writing variable names that I would like to mention to you. First of all, remember that variable names cannot have spaces in between them. So for instance, you cannot type a variable and say, let's say marital, and give space. Where is it? Great. It's going to give you an error. It says variable name contains an illegal character. Okay, so that is one thing to note. Okay, so if you pay attention now, another thing to know about variable naming is that it cannot start with a number. You cannot start any variable name with a number. And your variable names usually have to be about 64 byte. So if you bring it to Unicode terminology, you're looking at not more than 32 characters. So this cannot take more than 32 characters. You need to make sure you're within that. Special characters, yes, you can put some special characters. There are a few special characters that can be in the naming of a variable, and these include the hash symbol, the dollar sign, the dot or the period, the underscore, and then the @ sign. However, you shouldn't use those to begin the naming of the variable, because those can play some other roles in data analysis in SPSS. So it's always good to make sure you give a name that begins with a letter. Numbers cannot begin a variable name. The other thing is your variable name needs to be unique. It needs to be unique because that is a name that a system is going to recognize. So you cannot have ID here and have another ID. So the system is going to say, well, this variable name duplicates an existing variable name. So that will not work. All right. So once that is clear, now I want us to move very quickly. We want to spend time actually looking at how we can conduct a real analysis, okay, for our research. So today we're going to, if you have your SPSS now opened, we're going to try to go to variable view, all of us. We're going to be entering some data. The ID, remember, we've done this, we've made it nominal. Okay. All right. So we will, let's say we want to deal with a few more variables. So let's have age. And if you look at age, remember we are going to put it in numbers, right? So it's definitely a numeric value. For age, I don't think we will round it up to 0. We don't want any decimals. Of course, the full label will still be age, or age of student, or age of whoever you're dealing with. So over here, yes, let's say we can say age of student. Yeah. Then the values, of course, age carries a lot of figures, and we definitely will not have the time to define age groups with 1 or 2 or 3. No, that wouldn't make any sense. If they were in categories, let's say 0 to 10, and 11 to 19, 20 to 48, 49, then we could say, well, we could assign them to some values. But for this purpose, no, we wouldn't do that. And we will leave missing values. We could put in 999, and then we leave the rest as they are. So as I said, you can see that immediately I put in the age, another measurement level has popped up, which wasn't here initially, because the system understands that this ID, a string, variable, cannot be a scale no matter what. But this age is a scale, and so it automatically puts that there. All right. Now let's. I think another one we can do. Um, right. So we can do education, level of education. So let's do edu level, and we will leave it as a numeric value as well, because we will define it in the values. Um, we wouldn't need any decimals, so we'll leave that to 0. The level of education. Now, when we come to values, we will quickly maybe assign some values. We would say, well, maybe this is primary. Excuse me. We would say this is probably JHS, or junior high school, as we say here in Ghana. And then we would have senior high school. And then finally, I think we would have, let's say, tertiary, just to capture, colleges and universities all at once. Okay, so that is defined. Mission values, let's leave it. We don't expect to. Yeah, so now if you look at educational level, I'm going to ask you now, what kind of measurement level do you think educational level belongs to? Is this a scale? Is it a nominal? Or is it an ordinal value? Okay, so I'm sure you have, I'm sure by now you have answered this question. I don't know if you're able to send in any messages at this point. We activated that. Okay. All right. So remember that in terms of this, is it quantifiable? Okay, when we say educational level. So those are the things you should always have at the back of your mind. We could look at another one, let's say uh, sport, favorite sport. So I'll just put favorite sport. And over here, we'll leave it at numeric, no decimal places. And then, okay. So there are so many kinds of sporting activities, and you're not sure if all of these can be defined. Okay, so for that reason, uh, we would leave this so that it can be entered by the participants. All right, let's do one more, monthly income. Let's do monthly income. Okay, all right. So is this going to be also, is it going to have values or not? Yes. So you know that we cannot, of course, there are so many different amounts that people are going to mention, and there's no way we can define them in a structured way. So that will be left with no defined values. Now, what kind of value are we dealing with here? It's a number. So we are dealing with what? A scale figure. Okay. All right. So with this, we want to quickly move to the data view and see if we can enter some data. Okay, so you see the space that has been created for monthly income is a bit small. So you might just want to adjust the width a little bit just to take care of that so that everything appears properly. Okay, now, so let's say we have our first ID, age is 15, educational level. So, you know, we programmed educational level with ones and twos and threes and fours. But in order to know what is one, two, three, or four when entering the data, it's good to be able to, you know, activate the labels, the variable name to show even as you enter the data. So to do that, you will find this very icon. See this tab over here. We're going to click on it. That way, once you have that label activated, anytime we type in one or two, the actual label will pop up just to make it easier to read. Okay, now favorite sport. So here, let's say basketball. Okay, so you notice quickly that when I was typing, I couldn't type in any more numbers, any more letters, I should say. This is because the amount of characters, number of characters we allowed in the in programming in the variable view for this particular one was 8. So it could only take 8 characters. So to be able to take care of this, we need to increase this number to, let's say, 15. Okay. So then I'm able to type in all of it, basketball, and then monthly income, let's say 100 to this. Then we come to ID number 2. The age of this person is let's say 18. They are in let's say 2. So they are in JHS. They love volleyball, and their income is 50 cedis. The third person is 24, also in JHS. loves football, and earns about 150. Fourth person is aged 26, is in tertiary, and loves football as well, and earns about monthly income of about 250. So this is just for our analysis purposes. These are not real stuff. Okay, then we have another 17 years, happens to be in JHS, so that's number 2, and loves volleyball, and earns about 300 cities. Whatever he does, we don't know. Okay, so there's another one. So 25 years, also in tertiary before, and then also loves basketball, and earns about 240 cities. We're going to just do about 10 of that, and we should be fine. Okay, 16 years, also in primary. Loves volleyball, and earns about 125. Then number 8 is 14 years. It's in junior high school. So we have 2 there. Also loves football, and earns about 80 Ghana cedis. Then we have this next person who is about 6 years old in primary school. Loves volleyball. I have right, and earns about 30 cedis. Then we have finally we have 13 years, who happens to be in JHS. Should back to loves football. How many in basketball? Okay, that should be okay. And ends about 170 cedis. Okay, so now we have some data that we can begin to analyze. Okay. Now, when I was talking about the measurement levels, I asked that we paid very critical attention because your ability to conduct good data analysis is based, okay, it's basically based on your ability to understand um, these measurement levels, whether a variable is nominal, whether it is scale, whether it is ordinal. You need to be able to tell if it's a categorical variable or a continuous variable. Okay, so I'm going to want us to add gender quickly. Let me say sex. Um, yeah, and we're going to just define that as 1 being for male and 2 for female. Very quickly. Okay, so then we have that. And we will leave that to be a nominal value. Okay, because it's sex, it's a categorical value and it's not a defined quantifiable number. What we mean is there is nothing like someone that is more male or more female than the other person. Okay, it's just the name of a thing. It's like religion. You talk about different types of religion, okay, or different types of schools. Not educational level, but schools. Okay, so it's not ordered. They are just names of things. So male is just name of things, and female is just. So we can say this is not ordinal. There is no grading in it. One is not more than the other, and it's not scale, of course, because when we are entering this, we are talking about sex, male or female. We are not dealing with numbers that any kind of operational, mathematical operation can be conducted on. All right, so with that, we are good to go. So let's quickly just assign, some, yeah, so right there, we're almost done. Great. So this is what we have, our data. Okay. Now, for you to be able to start data analysis, you need to understand the common types of analysis that are done in SPSS. First one I'll talk about is when you have to compare one categorical value or variable, okay, with another categorical variable, okay? For instance, if you take educational level, this is a categorical variable. And if you take sex, this is a categorical variable, okay? Now, if you want to see the relationships that exist between these two categorical variables, what type of analytical tool do you have to use? You would use a tool that we call cross-tabulation, okay? So you will go to Analyze, okay? You go to Descriptives, then you go to what? Crosstabs, okay? Now, usually I would want the sex to be in the columns. So let's say we want to put sex in the columns, and then we want to put level of education up here in the rows. Okay. So with this, we don't even need to do anything. We'll just press OK, and you have some data already popping up to give us some kind of information on what we need to do. Now, if you look at the output that we just received, you see that in primary school, it's basically telling you, it's breaking down everything and letting you know the relationship is, we have 3 males in primary, 1 in junior high school, 2 in tertiary. We have 0 females in primary, 4 in junior high school, and 0 in tertiary. Okay, so already with this type of cross-tabulation, you are able to break down relationships by the categories. Remember, when we took the variable on gender, we have 2 categories in the male and female. When we took level of education, we have 3 categories: primary, junior high school, and tertiary. So your ability to break down all these categories and be able to have data on each of them broken down for you, you need to use cross-tabulation. I'm just going to close this very quick. Now, let's say that you want to do an analysis of crosstabs, and you need some additional information. Okay, so remember, these are you're not able to conduct any relevant statistics because you have something like gender, which is a categorical variable. It's not a continuous variable. So some of those, but we want to see some percentages. Okay, in our data, we want to see what is the percentage per these categories. So we'll quickly come to, you click on cells, and you click on what? Percentages. So we want to do for columns, so that the percentage under male female disaggregation. So we're going to quickly come here and just click continue. And when we do that, immediately we have this broken down for us. So when we take just the category of males, we are 50%, okay, of males, not against females, okay? 50% within the male category, 50% are in primary, 16 are in junior high school, 33.3 are in tertiary. So immediately you have this, and you are able to quickly use this data for your thesis or your research report. Very, very simple. Okay, now the next thing, which is even most common, where you normally start all your data analysis from, is what you call frequencies. So we're going to talk about frequencies in just a bit. But I have to break crosstabs just to open up your mind to understand that all these categories, the measurement levels are very important. When you have categorical variables, there's a way to analyze them against each other. If you have continuous variables and you want to compare them to categorical variables, there's a way to do that. If you have continuous variables and you want to compare them to continuous variables, there is a way to do that as well. So now let's do something on frequencies. All right, so I can see that okay. So very quickly, we want to look at frequencies. If you want to do frequency analysis, I mean, when we talk about frequency, basically you're talking about counts, okay? How many things, how many of this is here? And so it's the simplest form of analysis. It's the most common of all the analysis. And there are a few other things that you can do in there that we will also explore very briefly. So to do that, you come to analyze, you go to descriptive statistics, you go to frequencies, and then all the values that you want to have frequency tables for, you move them to this column, this very empty, this blank space titled variables. Okay. Now, one thing I want to say about frequencies is that it gives you a lot of information on every value that has been input under the variable. Okay. So, for instance, if you have age, you can imagine that there are so many different types of ages here: 6, 13, 17, 26. All of them are going to come in tables per row, and that will make your table so long and clumsy. So it's always good to apply frequencies mostly to, as it were, variables that have less categories. Okay, for instance, if you take sex, you're only dealing with two different categories, males and females. So it's easy to represent that in a frequency and just move on very quickly. So let's try that. Let's move gender over there. Let's move level of education. Let's move favorite sport. Now you see the monthly income, these scale values, they have a lot of different numbers under them. You can do it, but just that the tables will come out a bit clumsy. So I'll show you that in a minute. So with this, we quickly just press OK, and then we have the counts. So these are the summary tables that are going to show you, you know, how the distribution of the various numbers that have been generated through the data you have fed the system. So this is for gender. You see males, so basically frequency tells us there are 6 males and 4 females. The percentages are there. The valid percent, then the cumulative percent. Sometimes you wonder, why do we have these two in there? The purpose of these two is that now when there are missing values, these two will have, you would not actually see the same value showing here. Okay, one is cumulative. The valid percent is based only on what has been provided. It doesn't calculate for missing values. Okay, so if you go down here to level of education, you see that you have 30%. The valid percent is 30 for primary, 50 for junior high school, and 20 for tertiary. Cumulative means that if you add the first item to the percentage of the second one, you should have this item. So if we add 30% to 50% under the valid, we should have 80% cumulative. And if we add 80%, 20%, we should have 100%. So this comes out even more clearly when there are some missing values. But basically, this is what you get as your frequency table when you begin this type of analysis. Okay, yeah. Right. So I want to begin to. I just want to show you something very briefly about formatting your table to look like what I have. I'm sure some of you don't have your tables like this. Okay. I'm sure some of you have something else that looks a bit different, you know, from this. So I just want to show you how you can work on this. Now, So I want to change it to academic, the default. That will come like the way those other ones usually come out. Okay. Right. Okay, so if you don't have a table that looks more like a table that can be used in research, because your table formatting is also important in your research work, okay? Your APA research work, the table formatting is also very important. Um, if you want to change that to fit the APA standards, okay, depending on what version of SPSS you're using, I'm using version 26. Normally, with the version 26, it already comes with an APA style table look or table style already. So it's easy to select that. You can just right click on your table, you go to edit content, then you go to view, then you right click again on the same table, you go to table looks, and then you will select APA times New Roman 12 point. So it makes it very easy, and it immediately takes it to formats the table to meet the APA standards close to it. So you are able to use this table in your research paper. Now, if you do not have that in the version that you're using, this is how to go about formatting your frequency or whatever table you get in your output. All right, so you right click again, as I mentioned earlier, you view in viewer, then you right click again. Then you now go to what you call table looks. Okay, all right. Um, you click on edit look. Once this opens, you go to edit look. And when you click on edit look, this whole interface opens up for you. Okay. So then all you need to do is that you are going to change everything from here to Times New Roman and assign it, the APA standard format requirements. That is Times New Roman. The font size will be 12, and then no bold, no italics, nothing. Okay, then you make sure your alignment is left aligned. Okay, so you click on the area. You can click in it here actually, but you can just select it here so that we can start from the very top. You click on title, then you come to, okay, the font type. You select Times New Roman. You can just press T on your keyboard. It makes you press T 2 times. It makes it easier to locate Times New Roman. Then you come to the font size. You type in 12, deactivate bold, and you align left. That is all you need to do. Then you click. You don't click OK yet. Then you go to the next. The same thing. You do the same thing. You go to 12. Once you align the first time, it assumes left as the default and the bold is out. Then you go to the next one, corner labels. You do the same thing, Times New Roman 2 times. You go to 12. Then you go to the next row labels. You get Times New Roman, press T 2 times, and you are there. Right. So you go to the next until you are through with each and every one of them. Okay, so I am just done. This is the last one. I hope you are following as well. If don't worry, if you're not able to do every one of it, you can still follow with the lecture. and you can always practice it on your own later. It's very important that you understand the process. Then you can do that on your own later. Once you are done with all those segments, you see that all those bold and all those things have been taken out. It's all been changed, right? So then you just click OK. When you click OK, then you save it as. Okay, you need to save it as because it has become a stable style. So you need to save it with a .stt file extension. So for instance, you can save it APA standard, okay, or whatever name you want to give it, just to be sure that it's an APA table format style that you've created. Then when you write the name, you need to save it where IBM SPSS has what do you call it? The table looks folder. Okay, if you're using a Macintosh, if you're using a Mac, you need to go to applications, go to IBM, go to SPSS or statistics, and locate the version statistics you're using until you find the folder looks. Now for Windows, we're going to go to Program Files. Going to go to Program Files, go to IBM, go to SPSS, go to Statistics, go to version 26, and then we're going to look for looks. So this is looks that we have here. Okay. All right. I hope that wasn't too fast for many of you. So like I said, you go to your C drive on your computer, you go to Program Files, go to IBM, and navigate to SPSS. You navigate to Statistics. You navigate to your version. Yours might be 22, 25, 26, whatever it is. You double click on that as well. Then you look for the folder looks. So this is where you're going to save your table look style. So you look for looks and then click on save. All right. So you do not have permission, but this should work just fine. Should work. But if, let me see. I don't know why I'm having that error, but it should work just fine. If it does not allow, you can still save it somewhere you can remember, okay? Because we are going to upload it, so that is all that matters. But the best place is to keep it in that folder. So okay, so I'm just going to save it somewhere here. There's another SPSS folder somewhere here. So let's see, great. All right. So then, now that you have saved it, all you need to do is to browse and go to where exactly you saved it, the very folder where you saved it, and open. Once you open, you click OK. And then that is about it. You shouldn't have any more challenges with that. Okay. Right, so now that we're done with that, I want us to proceed with the analysis. So we did frequency tables, and I just showed you how to format your frequency tables to fit the APA styling. Okay, because you're going to copy some of these tables. For instance, let's say you copy this, and you need to paste it, okay, in your report. So you need to make sure that the tables are showing in a way that is suitable for you. Okay. All right. So let's get back to our data. So we just talked about frequency. Let's look at a few more things that you can do with the frequency. Now, as I mentioned earlier, you realize that some of these tables, we may not be able to do any real statistics on them. For some of the variables like gender, we can do mean, we can do median or mode for gender and all that. And for some of those general things. So, but we can have some charts, let's say a bar chart, and have some of our frequencies displayed. So you click on charts and all of that. Okay. Yeah. I'm going to speak about central tendency in just a bit. So if we add charts, you see that we're going to have some charts coming up. These are bar charts for gender. So very quickly, we have some representations here. We have a bar chart. We have a bar chart for favorite sport and level of education. Okay. Now, if we were to do this for age and, okay, so I'm just going to reset this. Let's do for age and monthly income. And let's try to see if we can get a bar chart for these and also have the frequencies. Okay, so you see a long table with all the numbers. So if you had 1,000 numbers, different age numbers, of course we can have 1,000 age numbers, but let's say you have up to 75 or 80 or 90 years, and each of them are different. All of them are going to be listed here. If you have monthly income with different types of numbers, all of those will be listed, and that will be a long table that you can really manage and do anything relevant with in your research report. So you see the age of students, this is how it came out in the bar chart. It doesn't really meet the purpose of research analysis. And so you want to avoid putting scale figures for these kinds of analysis. But there's something that can be done. We can easily do statistics for these. We can calculate a mean. So under central tendency, we can do the median, we can do the mode. We can even do standard deviation. We can do variance, we can do minimum, and all of that. Okay. Now let me just explain. Mean basically means average. So for most of these kinds of scale variables, the main kinds of statistical analysis you want to do is to discover the mean of the distribution. Okay, what is the average number of all the ages that are listed? What is the average? Okay, what is the median figure? What is the mode? Mode is the most recurring of the number or the age that is most frequent throughout the distribution. And so you want to, yes, so standard deviation tells you how dispersed, okay, the numbers are from the mean. All right, and the minimum will tell you the minimum value in your distribution and the maximum value in your distribution, and so on and so forth. All right, so with that, we can just click OK, and maybe we can find some data over there. See, we can have something nice. Okay, so again, we still have those frequency tables showing. All right, but this is where I want you to focus on. I want you to look at the statistical table. Okay, so you'll find this very beautiful table that summarizes a whole lot of important information that is needed. Okay, so there's so much that may not be useful, but this table serves a very useful purpose, right? I'm going for a very long frequency table of counts. So over here, immediately it tells you the number of valid counts. You have 10. No missing values have been recorded. For the category of age, category of monthly income. Now the mean for age has been recorded to be 17.40. So for all the ages we have, our average age for all the categories is 17.4. And then the median is 16.5. So in the middle, we have someone that is about 16 and a half years old. Then our mode is 6 years. Okay, so that is a standard deviation is 6. 0.186. Now, I will say something briefly about standard deviation. Now, remember that standard deviation talks about how close, your figures or your distributional numbers are to this mean figure. Now, with this huge standard deviation figure, because once it's more than zero, the farther away your standard deviation is from zero, the less reliable the mean is, the information that we're getting is, okay? So you can say that, well, with a standard deviation of about 6.186, our mean is 17.4, but it is not something we can rely on 100% because we have quite a huge standard deviation. Now, the same thing applies to the monthly income. Of course, so the minimum age is 6 and the maximum age is 26. So all that data is there. With the monthly income, you have a mean of 149.50 cedis. That is if we're operating cedis. The median is 137.5, mode is 30, and the standard deviation is 9. This is a huge standard deviation figure, telling us that our ability to rely on this mean is questionable. But of course, there are other kinds of inferential statistics, other kinds of analytical functions that need to be carried out to check out the significance of these figures and all of that. But today we are not going into that. Let me just mention that we will be having another course sometime in the coming month, and that will be a more detailed, advanced data analysis course to go into a lot more complex analytical functions, regression, ANOVA, and all of that. So for this, we will not be going into some of those details, but I believe that once you are registered for this course, we have your email and we are able to send you a reminder on that particular course that will be coming live in the month of September. And that is going to be a paid course. It's not going to be expensive, most likely about just $20. But for those of you who have been part of the community data zone work, you would have some good discount to about $15. So I will give further information on that through email in the course of time. Now let's get back to our analysis. So another way to do these types of analysis is basically to do, instead of using frequencies, remember that the frequencies, when we do this, we are able to deactivate the display of frequency tables, okay, to prevent these types of long tables from showing. And if we do that, we can easily have a nice histogram and we would have a very, very nice presentation. Now, you notice that with the histogram, the data that is, even the charts that have come are different from the bar charts that came earlier, okay? Now, so that tells you that when you are dealing with scale or continuous variables, you are better off using histograms for graphical representation rather than bar charts. Bar charts are appropriate for the other types of variables, the nominal variables, okay, the qualitative and categorical variables. So you see that we have a very nice distribution here, also showing the mean information, the standard deviation, and all of that. And then our summarized analytical statistical table. Okay, now another thing, let's close this output data. Another thing we can do is to use descriptives to do our analysis. Descriptives, immediately I open descriptives, you will notice that there are certain variables that are not available on the left. I believe you've noticed that, because when we did frequencies, you would notice that we had quite a number of them. Let me bring all these back. So you have about 2, 4, 6 different variables, okay? But when we did the descriptives, You realize that we only have 4. Okay, so every string variable, every variable that deals with text has been removed. Mainly because we are unable to perform any kind of statistical, meaningful statistical operations on such variables. So descriptive is a way to help you to have many numbers on multiple variables in a very compact window, in a very compact manner. All right. So for instance, all these things here, we can actually set all of them and conduct a descriptive analysis, and we wouldn't have a huge, space of tables like we did under frequency with all the counts being listed and all that. This immediately just gives us some very important statistical information, letting us know our average, our mean, our minimum and maximum, our standard deviation. So this is one way to get very compact information that is easy and straightforward to the point. Okay. All right. So while frequencies deal with counts and all that, and of course you can do some of this statistical analysis in frequencies, but using descriptives makes everything a lot more simpler and easier. Now let's try something beautiful here. I'm just gonna, all right, so I'm gonna click on options. Okay. So these are all the kinds of things we can do here. You can select the skewness, ketosis, and all of that. All of those can be calculated as well. Okay. Now, those of you who have some background statistics and know about z-scores, or what you call standard scores, in dealing with z-scores, all you need to do in descriptives is to click this, and then you have your z-scores. This particular course is not going to go into talking about z-scores, but I just want you to have an idea what that is all about. Okay, so over here you see that we have our standard error. The skewness is there, so standard error is there, standard deviation, and all these statistics have been indicated just by doing a descriptive analysis. So descriptive, it sounds just like the word, descriptive. Now, when you come back to data view after that analysis, you now see that we have some new columns that have been created after we did that analysis. So we have the ZH, the ZADU, Z monthly. So these are figures that are standard scores because we selected the standard score, function. But we will not go into the purpose and usefulness of these numbers today. Okay. All right. So now we are continuing with the analysis. I just want to talk about. We've just talked about crosstabs, where you are dealing with categorical versus categorical. Okay, I'll go over that when I'm about to finish the lesson. And then we have talked about frequencies and descriptives, which are very common types of analysis in SPSS. Now let's talk about, let's say you have, you want to analyze this categorical variable sex, okay, with monthly income. How are you going to do this? Because monthly income is continuous and the sex is categorical. So to do this, to know the relationship that exists between this and this, you have to do something we call comparing the means, means comparison. So let's try that for you to see what I'm talking about. Now, you click on Analyze, and you click on Compare Means, and you click on Means. Okay? Right. Now, with this dependent, this segment will usually carry the variable that has scale, values or properties. So the scale variable goes into the dependent list, and then the categorical variable goes into the independent list. Okay. So we want to see the relationship how monthly incomes are distributed based on the categories of sex. All right, so we will just put monthly income here, and we'll put gender here. Okay. We already have mean. We're going to get the number of cases and the standard deviation. Okay, so I think this is just fine. We could add the median or range or minimum and maximum, but we can just leave it this way. That is fine. So then we click OK. All right. So immediately we do this, Excel processes and tells us the case numbers. Look at this report here, monthly income by males and females. So immediately, SPSS tells us that the mean monthly income for males is 132.5, and the mean income for females is 175 cedis. Okay, and then we have the standard deviation figures. So this is a very nice way of comparing a continuous variable with a categorical variable. You use means comparison to see the differences, what is happening, what is the standard deviation. Are there any similarities in the earning averages of males and female? Are there any nice relationships between the earnings, the mean earnings of those in primary school or JHS or all of that? So next we're going to try that. We're going to try analyzing data that has something to do with, yeah, so now let's just reset this quickly. And now let's try it with the levels of education, which is a categorical variable. And then this time we will deal with the monthly income again, all right? So we are still dealing with the same statistics. We're not going to change, or we can just add the median there, then we're fine, okay. Now, when you come here very quickly, you see this is telling us the mean income earnings of students in primary, students in junior high school, 150. The mean earnings of students in tertiary, 245 cedis. So this immediately gives you these relationships, and you can easily copy this table into your Word. So this is a beautiful way to undertake data analysis between a continuous variable and a categorical variable. All right, so if we are okay with this, I think that is simple and straightforward enough. Yeah, all right, so because of time, I'm going to move very quickly to us trying to look at, okay, let's do one final thing on the means comparison. We have a favorite sport. We have not done anything with favorite sport. So we will go to compare means. Let's look at the distributions by sports. So we want to see the earnings based on students who you know, love these various types of sports. So very quickly, we would put our monthly income up here and put yeah. So we're able to get a breakdown. Basketball lovers, their earnings are around 170. Football lovers, their earnings are around 162.5. Volleyball, 126.25. So very quickly, you have all these summarized for you by SPSS. Okay. Now, with that being said, we're going to spend the next minutes to look at one final type of analysis that you can do for your research work. Okay. Now, we've done general frequencies and descriptive analysis. We've done categorical versus categorical, where we said you use crosstabulation to look at the relationships between two categorical variables. Let's say sex and, of course, levels of education. Okay, or sex and the kind of sports that the children love. So if we try that again, we will just reset this. You see that the sex of the students and the type of sports they love, we are able to very easily get some good data on this. We know that 2%, 100%, okay, of males, they love this. Those who love football, those who love volleyball. Then the females, we also have that distribution. So we know who loves what. Just by doing a simple cross tabulation of two categorical values. Now, the final thing, we've also done continuous versus categorical, where you have a categorical value like maybe sex, gender, and we are looking at it against monthly income, which are scale or category continuous variables, or age. All right, so having done that, we want to look at continuous versus continuous variables. Okay, for instance, we have age being a continuous variable. We have monthly income being a continuous variable. All the others are categorical variables. Now, how are we going to compare age and monthly income? We cannot do that using cross tabulation. Okay, the best way to do this is to use what we call bivariate analysis. And so we're going to do something called correlational analysis. All right, so let's look at how we can do this in Excel. You go to Analyze, you click on Correlate, you click on Bivariate. Okay, now everything here, I mean, these are very important things, but we are not going to go into that today. What we want to do is how to conduct the basic analysis and have our Pearson values and be able to interpret the values to represent what we want. Now let's talk about correlations. Whenever you say correlation, basically what you're saying is that when there is a change in one variable, then there is a change in the other variable, either positively or negatively. Okay? So if one variable is increasing, then the other variable is also increasing. Or if one variable is increasing, then the other one is decreasing. All right, so basically that is how this works. So we are going to look at two continuous variables. Let's look at age and then monthly income. So we're going to put those two here. Then in the options, we don't have to actually do anything here. We have dealt with how to get means and standard deviations all along, but we can still put it here if we want. Okay. So basically, here we are. Here we are. So because we inputted something for mean and standard deviation, it's been given to us here again. Now, this is the correlation analysis that we just did. So when you see 1, it means that, I mean, the variable is being correlated to itself. And so that is why you have 1, and we don't need, that is not a useful information. We won't do anything with that. So if there's a correlation with monthly income, it comes down here. This one comes here. We don't need that. What we need is the Pearson correlation. Okay, 0.616. Then over here is the same thing, 0.616. So this is the figure that we are concerned with. We are saying that if there is a change in maybe student age, then maybe there will be a change in monthly income. Now we've done that analysis, and this is the number we've gotten. Now in Excel, in SPSS, you have a number, let's say a number line maybe from 0 to 1. Okay, but 0 actually means from negative into 0 to 1. Okay. Now, when you have figures, all right, that are close to 0, then you have a weak correlation. If you have figures that are close to either -1 or +1, then you have a strong correlation. That is the first thing to note. The second thing is, if you have a negative number it means that when one variable is increasing, the other one is decreasing. But if you have a positive Pearson correlational number, it means when one is increasing, the other one is also increasing. Okay? Right. So if you look at this value, we have 0.616. Now, we say that values are strong when they begin from about 0.7. Okay, either to the negative or to the positive. So minus 0.7 or minus whatever, if it is towards -1, or it is positively 0.7, 0.8, 0.88, 0.9 to 1, then you have a strong correlation. Now we have a figure that is less than 0.7. So what we would say is that this is not so strong of a relation. However, we could say that, well, there could be some level of change in income based on the age of students. Now, take note, if we had something more than 7, then we'll say there's a very strong, so in your report, your thesis report, you would say, well, there is a very strong correlation between age and monthly income, because the value that has been obtained, the Pearson value, shows that when age increases, monthly income also increases. Now, there are other kinds of tests that you can do to give validity to the Pearson correlation, which we will not be going into here. There are other kinds of inferential statistics that can be conducted as well. So this is basically what you need to understand when it comes to data analysis in terms of correlational analysis. Okay. All right. So at this point, we are going to go on a short break for just about 5 minutes. I want you to catch your breath. All that we have said, let it sink in. And then we'll be back for a few more minutes to look at another data file. And then we try to do some more data analysis just to help you to be well positioned to develop your research project report. Okay, so thank you so much for staying on so far. If there are any questions, you can type them in there in the Q&A session chat box. You can type them in there. You can post a question to me, and then we will proceed. Okay, so I'll see you in about 4 minutes from now. Okay. Okay, welcome back, everybody. Right, so as we've been saying, we want to continue to look at okay. So these are data we've been working on. One very important thing that we need to do is that we need to save the data. Now, it's going to be a disaster to input all this data, and then something happens, and then you lose all of it, because it takes a long time to input all the information that comes through your questionnaires. So you always want to save this, and we're going to save this in I'm just going to call this student preferences, and then I'm going to save it right, short course designs. Okay, so welcome back once again. Now we want to continue with data analysis. We want to, yeah, great. If you can see my screen now, I think, all right, so we have this data file that we would use to conduct some further analysis. Now, based on all that we've been saying, I have brought your attention to the fact that you can do basic statistical analysis using frequencies, using descriptives, using cross-tabulation for two categorical variables, for comparing of means for continuous and categorical variables, for bivariate analysis for when you're, trying to analyze two continuous variables. Okay, there are so many other kind of things that you can do when we come to the new course that we'll be having in September. Like I was mentioning earlier, this course will deal with all kinds of ANOVA, one-way ANOVA, two-way or factorial ANOVA, multivariate, multiple ANOVA, that's MANOVA, and all of that. We'll deal with regressional analysis. How do you do predictive analysis? Okay, how do you predict this can happen or all of that? So we'll do a lot of regression stuff and so many other complex kinds of analysis that are very key for us if you want to do academic research or you want to finish your project work as a master's, a first degree or master's student or as a PhD student. Okay, so now we have this table here talking about, some health related stuff. Now, based on all that we've done, okay, there are several other, of all that we've done, we can do so many other ones. But I just want to take you through a few more examples so that it stays with you. You understand what you're doing when you have your data in SPSS, okay? So you are able to define all your, what do you call it? You're able to define all your your variables, okay? The age is, of course, is age of respondents is not, it has to be a scale. Sex is nominal, education, yeah. So you're able to do all these measures of income, average monthly income. This cannot be nominal. This has to be a scale. And then, of course, the source of income. Yeah, right. So now, after you have done all this, and I explained to you what these things mean, okay? The types that you're putting here, the measurement levels, which are so important. If you don't have this right, it will be difficult to undertake a very meaningful data analysis. All right, so now when you come back to the data view, let's say that you need to analyze, the marital status of participants. Yeah, the marital status, whether they are married or not married, okay? We want to analyze that against the sex. We want to see males and females and which people are married, which are not married. Now, what type of analytical function are we going to apply? I'm just giving you a few seconds to think about it. Okay. Now let's see if you're right. Now, so sex is a categorical variable. Okay. And marital status is also a categorical variable. Those who are married, those who are not married, or divorced, or separated, or whatever the situation may be. Okay. So we need to be able to tell which groups of people, because we have two categories here. That is male, female, and here we have never married, married, separated, and all that. So we have our three categories. So we want to be able to know the relationship between these two. So immediately this looks like two categorical variables going to be compared to each other. So we immediately we know we have to use what cross tabulation. So we go to cross tabulation. Then we look for those two. Okay. All right. So we put our sex here, and then we put where is it? Marital status here. Okay. All right. So then let's say we also need some, percentages just to make everything easy. Of course, these are the observed values that we are dealing with. So you see the counts that have been selected are the observed, not expected. Okay. So this is used in some other types of analysis, which we are not mentioning today. This will be available when you join the paid course in September. Okay, so we just click continue and then click OK. We can choose to display clustered bar charts. Okay, that is not bad. And then okay, this is opened in some other funny way. I don't know why it didn't show up earlier. All right, so immediately you see that, okay, so you have cohabitation, married, monogamous, married, polygamous, never married, all of those. For females, we're able to tell 100% are cohabiting. Those who are, what do you call it? 100% of females are cohabiting. There are no males that are cohabiting. 145, so 86.8% are monogamously married. So you see all those divisions in there. We can reorder the display, show that we have marital status here. Right. So you see, then we have a beautiful bar chart, very beautiful. We have the male-female disaggregation. Here we have it. Okay, so the males and the females, we have 0.4%. Okay, so within just females, okay, within just females, this is a situation until we get 100%. Within just males, this is the situation. So this gives us a beautiful breakdown that serves on depending on the kind of information you want. Okay, this gives you a beautiful summary that makes data analysis interesting. Okay, now let's also look at some other variables again. Let's say that we want to analyze education with our main source of income. Okay, we want to analyze education with main source of income. Both of these are not scale figures, so none of them is a continuous variable. These are both categorical variables. So that again tells us that we still need to use cross tabulation to get any meaningful data or meaningful report or interpretation from the data. Okay. So we want to know by education what are their main source of income. Okay. So then let's go to descriptives, go to cross tabulation, and then so we can put education up there, and then we can put main source of income in here. Right. Okay. So you can see under no education, how many are artisans, how many are businessmen, how many are farming, and primary school, how many are artisans, all the groups we know, how many are farming, how many are fishing, how many have formal employment, and so on and so forth. So like I said, everything depends on your understanding of the measurement levels, okay, of categorical and non-categorical variables. Then you know what type of function to activate. So with this, we know that if we want to analyze this in this, we need to do cross-tabulation. Now, let's say we want to analyze education against age. Now, age is a category, is a continuous variable. It's quantitative, and education is qualitative. Okay? So what are we going to do? We need to be able to compare means, because when we have continuous and categorical, the best thing to do is to compare means. And remember, when we go to analyze, we will go to compare means, and then we have this. The scale must always go to the dependent list up here. Okay, the scale variable. In this case, that will be age. Okay, and let's put the categorical variable level of education in the independent list. Okay, and let's see, we're gonna have all these statistics. Okay, great. Let's see what we have. So very quickly, we know that by level of education, we have the mean for those children with no education, the mean age is 38. The mean age for those in other categories is 40. The mean age for those in primary school is 32 years. The mean age for secondary is 27. And we have all the standard deviation figures as well given to us over there. So then in summary, this is just how to proceed with these types of analysis. The final thing we'll try again is to do something that has to do with two continuous variables, let's say age and monthly income. Okay, so remember we said we would have to do what? A bivariate analysis. It's a correlation. Okay, so we have average monthly income, and we have the age of the respondents. So then when you click OK, you're going to have this very beautiful table here, and it gives you the the Pearson value, the correlational value, and here we have minus 0.007. Now remember what I explained earlier. Now in statistical distribution, if you have from -1 to +1, those numbers that are closer to -1 and those that are closer to +1 tell us that there is a strong relationship or correlation, okay, between those variables that we're trying to look at. But if we have values that are closer to 0 in the middle, then we have a weak correlation. Now the strongest correlations begin from 0.7. Now if you look at what we've received, we have minus 0.007. So already this means once you have a negative value, it means when one variable is increasing, the other one is decreasing. So in this case, when age is increasing, then monthly income is decreasing. However, the relationship is weak, is very, very weak, because minus 0.007 is much, much, much closer, to 0 than it is to 1. And so we would not say there is any significant relationship. We would just say, well, there is no correlation, and if age increases, nothing happens to monthly income. If age decreases, of course, age does not decrease, but thinking of it in terms of reverse numbering, there will not be any impact on monthly income at all, whether people are young or old, it's just the same. Whatever we have is what we have. So this is how to do these types of analytical, you know, operations. So at this point, I want to bring this segment to a close, and I want to encourage you to continue practice. When it comes to data analysis, the best thing is to keep practicing, input data or get some data that you can get, and continue to practice. Practice and master the variable, defining your variables, the measurement levels, get used to this very well. And then practice all that we've done, the frequencies, descriptives, bar charts, histograms, correlational analysis, means comparisons, bivariate analysis. So remember, frequency and descriptives are univariate analysis. Okay, so those are already taken care of. And continue to practice this until you become very comfortable. And then I believe you'll be ready to participate in the paid course that we're going to have in September. As I said, that is going to be $20. But for those of you who have joined this particular training today, that will be a discount we'll be giving because we have your emails. And if you are registering, then you have $15 to register. So further information on that will be sent through email and communicate to you when we're going to have the date and the payment structure and method and all that. So that is going to be a fantastic session where we're going to go into very complex analytical systems, analytical functions, as I mentioned earlier. So get ready for that. Let me mention that we'll be having some courses. There were some courses, I think, 2 months ago. We would have another course in data collection. Okay, basically because if you know how to do this analysis, but you're not confident, you always need to depend on some people to get you the data, then sometimes you are not sure the kinds of data you are getting. So I'm going to be teaching the basics of data collection using a Kobo toolbox or and a few other softwares, ODK, and possibly Comcare. Or even ArcGIS online. So I'll teach how to collect data and then how to clean the data. And then you can begin to even transfer some of the knowledge to SPSS to be able to undertake these kinds of analysis that we're talking about. Then from there, we should be having some more courses in visual data visualization, using Excel dashboards. How do you develop Excel? And then also Power BI, Microsoft Power BI, and possibly Tableau. So I will be bringing some of these to you. I encourage you to continue to watch out for email notifications from Data Zone. And I believe that we will have very good times whenever we come together. I wish you all the best. And if you have any questions, if you have any other things, any other follow-ups, or any other thing you want to ask, you can always send me an email. So I'm just dropping this now. Right. So thank you all so much for joining today's session, and I hope it's been good. I wish you all the best as you continue to journey on in this data world. Okay, so thank you so much for coming, and do enjoy the rest of your evening or your day, depending on where you are connecting from. Okay, so bye then. I'm going to stop the recording now. Thank you all.